Okay, welcome to session 6 of track 1. I think it's track 1. I hope it's track 1. Proactive migration keeps the people in the picture. I'd like to welcome Lubosz Kosnik to talk all about that. Take it away.
Hello, hello, hello. So, code of conduct. We do have a code of conduct. Be nice. Don't respect everyone. Our sponsors, if you do want to donate, we do support the National Museum of Computing with all of the donations. These are our sponsors. And tweet and specify everywhere. Share the knowledge about the meetup. So the proactive migration roadmaps keep the people in the picture. What I'm going to try to tell you today is the story of myself, my company, how we, even though we had a fully working system, solution, and processes, how we and why we decided to change them. Agenda, I'm going to do a quick introduction because it's impossible to understand the problem and why we come up with the idea that it's a problem without understanding what we're doing and who we are. After that, I will briefly talk about the systems, how they work with each other, how we are doing, how we're providing the system and functionalities to the clients, what we decided to do next, and the company's role in the whole process. So, introduction. We're fast, and it's not only the name of the company, it's also the idea, what we want to provide to our clients, how we want our systems to behave. So the screen you're seeing, that's our checkout flow. The product which our company provides is a checkout for any and every e-commerce on the world. We do want to do the process to be as simple as possible and as quick as possible. So the whole our product is built around a passwordless world, around not having to fill a long, lengthy forms. And to make the whole process basically a one-click checkout. You're seeing a fast checkout anywhere available. You're pressing this button, and in basically seconds, you're getting products ordered, paid for, and almost delivered to you. So how all of that works from our side. So that's the life of the request in our system. It's even more than just life of the request. So you can see the protobuf, and the protobuf really, it's like a heart of our whole system. Everything, the whole backend systems, all the infrastructure, all of the systems, they do use protobufs to talk with each other. Because of that, we do have a really standardized way of exchanging information between the systems. The schema is well defined. We well know what service is gonna be exchanging, what kind of information types, and all of that. So it allows us drastically to minimize the overhead of like creating APIs, creating schemas, and acknowledging who's going to be sending what in what type. Then we do use those protobufs to generate the gRPC servers, which do provide us like the service-to-service communication. The backend services, they use heavily gRPC and protobufs as a data schema, as a way of exchanging the information. Because of that, we do have a really high visibility into everything what's going on. We do produce metrics. We do have information about the latencies, about the throughput, about the how many requests per second each server is handling. And then the next thing, how we are using protobufs, we do expose an API services. We have a direct integrations, like the clients directly integrating with our system, with our checkout flow. So we do use envoys, which do provide us with a way of exposing proto descriptors as REST APIs. So it's a fully automated process from us, from our side. We do have, again, our developers, they create protobufs, they store them in GitHub, and then as a part of the release cycle, those protobufs are being loaded into envoys, deployed in our infrastructure, which gives us an easy way of exposing JSON, I'm sorry, JSON REST APIs, which are one-to-one with the protobuf specified. So there is no problem with transcoding, exchanging data formats, or any of that. And the third step, how we're using our protobufs, is Swagger. So for the front end, and this is really where the problems where disconnects is starting to show up drastically. Our front-end services, they use Node.js services, they use the GraphQL mesh specifically, which requires them to provide Swagger files. Again, because of the decisions which company made about the technologies and systems which we are using, it's a well-defined process. We do have protobufs, we do have generators which take the protobufs, they generate swaggers, and then swaggers are being provided to the front-end teams, which are able to load them. And because of that, they do know how to communicate with the REST APIs. And the front-end services, majority of our services is written as React front-end applications, which do have a specification of the GraphQL types, and they do know how to talk to each other. The main thing you can see in here is the GraphQL mesh. It's really yet another layer on top of another layer of transcoding. And the problem, it's not super powerful. It's not super performant, which again, getting back to the values of the company, it's really important for us, for our clients, for systems to be fast, to be performant. So how it's powered? Monorepo. Monorepo is in the middle of the whole company. The whole source code is built around Monorepo, which means that backend developers, front-end developers, they all store code in the same place, which gives them a really high velocity of doing changes. They can do refactorization across the board in all of the systems, which allows us even to change the processing. Instead of having dedicated product teams, we can have a product lines. So the difference is that the developers, instead of working on a single specific application, they can work on a specific features spreading across applications. And again, because it's all in the monorepo, it allows you to easily go over, create a change in all of the systems in a pipeline. And because of that, you can deliver a feature across the board in all of the systems. To get this working, because monorepo, it means you have hundreds and hundreds of projects and separate services in a microservice world, which are stored in the same place. So you do have to have a scalable way of testing them, of building them, of verification if everything is still working as expected. So for us, it's Bazel. Bazel, it's a Google product. It's a hyper scalable build system which allows you by writing simple manifests, you can specify how to build, how to test your application. But the main point is that each manifest for a separate entity. So let's say you have a front-end service build. For the front-end service build, you can, or for a build of anything else, you can specify the dependencies. So Bazel, instead of just building and testing your application, it's really, really good at analyzing trees of dependencies, which means that whenever you're going to do a single change in a single point in monorepo, Bazel will know what this change affects by having those dependencies specified. It knows that if you're going to change the protobuf, that protobuf is being used then for gRPC, or it's used by the swaggers. So changing a single protobuf, for example, will trigger multiple different operations being executed, which then by changing the protobuf, you may run the front-end tests because they are being connected by the dependencies with the protobufs. And the same, the backend services, they are being tested, they are being built because of the dependencies trees. The next step from the communication perspective, as I already said, gRPC and protobufs, they are building stones and the most fundamental ones for the whole backend communication between the services. By having protobufs, we do have a very, very strictly and well-defined messages which systems will exchange between each other. By putting a gRPC on top of this, we are getting a best possible performance available on market. There is no more powerful and quick system or like the transport protocol available on market. So because of that, the company early on an early stage, they decided that gRPC and the protobufs, they're gonna be everywhere. The whole backend infrastructure, all of the backend systems, they're gonna use those. It's very, very well standardized. It gives an easy way of changing, of tracking changes. There is no specification of JSON schemas or whatever, which are being complicated by, like, they're hard to read, hard to understand. The protobufs are very well defined, and also having gRPC, it gives us a backward and forward compatibility, because gRPC has a functionalities to process even requests which do use a previous version of the protobuf. Or they have a newer version of the protobuf, but server doesn't really support yet that version. So that's the functionality which we designed to go with for the backend. And frontend, it's a kind of new project, and especially it's a newer project for our company. We were using a different product before, but frontend team, they tried and they wanted to test out the GraphQL mesh. It's yet another server responsible for converting GraphQL queries into the REST API calls. It does allow for multiple configurations for a lot of data, like you can enable caching, you can write your own wrappers around the request, you can do multiple things with that service. But again, it's JavaScript, which I'm a reliability engineer, and the problem is that whenever I'm hearing JavaScript, it means it's not going to be fast. We do had a lot of struggle with this service, with like observability. We solved them, and right now we have a fully working, fully functional system. We do have a front end, we do have a GraphQL mesh server layer working. We do have everything connected by the monorepo, by Bazel, by testing. So we have all of that in place. So what's next? It works. As I said, it works, kinda. What's the problems are? As I said before, we do have this double transcoding issue. We do have envoys which do our transcoding from the REST API calls to the gRPC protobuf requests at the backend. As I said, we are we are heavy about observability. So we do want to know and we do want to see everything what's going on in our systems, in our infrastructure. Because of that, we do generate traces from everywhere. Whatever is capable to generate traces, it's gonna be it's gonna be generating them, and we're gonna be collecting them. We're gonna be analyzing them because we do need to know what's going on. So after the migration to the GraphQL mesh, after successful release and front-end team working on that, we started looking at traces. We started asking questions. Is there anything that can be better? The process, the protobufs to Swagger, as I said, it's a fully automated process. But again, it's a process. It's a thing which has to be done, which has to be generated. The Swaggers, we have to store them. We have to make them available for the front end. The front end, because of that knowledge, they know that they do load and work on Swaggers. They do expect that this is their input. They don't fully understand, okay, but where the Swaggers are coming from. So that created the problem with SAT clients. The clients were set on the company, on the product, because again, latency is a really important factor for us. So double transcoding, deliveries of the features. The backend developers, they do work on a functionality on the backend. They do create a protobufs. They do create PRs. They share them for review. But the problem is that the front-end team, they use Swaggers. So what that means is that they do wait for working on the implementation for Swaggers to be available. For Swaggers to be available, the PR has to be merged. They have to be created. So there is a huge disconnect between the front end teams and the backend teams, because they do look at the different things as a source of truth. And because of that, it do slow down the development cycle, which then again results with the SAT clients, because our clients, we are a startup. We have clients which want things a week ago. With that mindset, with that approach, we sometimes struggle with delivering features as soon as possible. And because of that, we do identify that if we're gonna try to streamline, to simplify the process, we may make this thing easier for our clients. And then from the clients, from the people's perspective, which are do use our checkout, by observability, by the traces, by all of the information we collected from the process, we figured out that Envoy's transcoding is extremely powerful tool. Overhead generated by the transcoding the REST JSON API calls to gRPC protobuf calls on the backend. It's extremely quick operation. It doesn't use barely any memory. It barely uses CPU. One single Envoy instance can transcode hundreds of thousands of requests per second, and it's not gonna see a problem, any latency spikes or anything else. The GraphQL mesh, it's a completely different beast. Node.js, they have their own memory management. You need to have a really defined and well thought people about JavaScript, which from our perspective, we struggle with this because the reliability and the performance teams, majority of the engineers, they have a background in different languages. They don't have knowledge and experience and expertise in JavaScript. Plus, those systems, they are complicated. Each and every one of them is complicated. It requires processes to manage them, to configure them. So because of that, unification of the process, streamlining, removing unnecessary steps. This is the things which we thought about to do. So as I said, front end, it even ended up with the situation that we do have a front end infra team. That this is the amount of the distinction and boundaries built around the technology which started to exist in our company. But it's a process. Everything can be changed. I am a strong believer that everything can and should be looked into. And if there is anything we can do, if there is anything we can figure it out to make it better, we should do it. So double transcoding, it was like it's a painful thing for us. We do see, and that's again because we do have an observability. We can see how much overhead the GraphQL mesh transcoding creates. Because of the technology stack which we are using on the backend, we do identify based on the traces and observability we built around our systems that the front-end GraphQL mesh transcoding operation from the GraphQL queries to API calls, it generates even more than 10x overhead on the backend calls, which is huge. If we would have a single backend call which is longer and lengthier process, it would be fine, at least like for some time. But having a front end on each and every call generate a 10x overhead, it's just way too much. We had to do something about it. So as a process for the migration, what we decided to do is the gRPC web. So if someone been on a presentation which ended before my one, you probably know more about gRPC web. It's not a super informed product. Not too many people are using it, but that's the thing what we come up with. Let's unify technologies. Let's drop the walls. Let's drop the boundaries. Why front-end team? They should be looking at swaggers. They should be looking at the protobufs as well. They should be considered during the review processes. Whenever backend developers they do create a protobufs for some feature, for some functionality, front-end teams should be involved in this process. And that's where the gRPC web comes from and comes into the place. It does unify the whole process. It removes double transcoding. It simplifies the process, which basically makes a less disconnected world for front-end and the backend developers. We don't need a front-end infra team really, because everything is basically provided by the backends and by the Istio service mesh, which is responsible for the transcoding. But basically what it does, I'm a strong believer for the unification and getting people together instead of like building boundaries, fake walls and all of that. So it's not just technology. It also means that we can really get people from a front end working hand to hand with people from the back end. Even though our company, we changed the way how we're targeting the products and lanes, instead of just having people working on a specific product or like specific service which is involved in a specific product. We are rebuilding the company to have people working on a specific product end to end. So they will take care from the whole development cycle from the front end through the transcoders, if they are any available, by the definitions of the protobufs and the backend implementations, which means that instead of having those separated teams which are working in silos, they are throwing some swaggers through the fence. we do have people working hand to hand with each other. So what's the company's role about it? Empower your people. That's the most important thing. Companies do hire talent. Everyone who's working in the recruitment process, everyone who's involved in the recruitment process knows that companies do want to hire talent. They do want to hire the best engineers available on market and the best engineers they can afford for. So by taking this into consideration, we do have to understand that if you were selected as a talent, if you were selected and you went through the whole interview process and the company decided to hire you, you know something what they need, and because of that, all of the members of the staff team, of the management, the higher management, they all have to understand that those people were selected. They went through a lengthy and complicated process with the recruitment, and they do have a knowledge which is required for the company to be better and to make the company to the place where they want to be. So this was the case in my case. Again, I'm working in a startup which does drastically simplify the whole process for me. I was hired by the vice president of engineering. I was not hired by just a normal manager managing the team. I was hired by the person on the highest position available in the engineering organization in our company. So it did give me a small handicap. Because of that, I was able, I had a direct, but that's the thing. Again, empowering your people. People should have an access to anyone and everyone in the company. So that's where the openness really of the company and people working in the company comes into the spot and lightning. You have to you need to give people a way of expressing and telling what they want to do. And it was not easy, for me to go to the whole organization, the whole engineering organization, and telling them, hey, I do want to completely destroy everything what we have, even though it's working. But because of doing this, not only I will change the technology stack, not only I will affect our clients, I will change our internal processes. I will remove the boundaries. I will allow you guys to work more closely with each other. It was nerve-wracking. I'm not gonna lie, but I know that in my company it was easy to do. If I'm gonna come up with a good idea, if I'm gonna have numbers behind it, if I'm gonna have everything well defined, people will agree and they will approve. But this is really where the company stands. Is important. Like the company can approve those processes. They can allow people to be the best engineers they can be, or they can be closing the doors and meeting privately and trying to figure it out. Are we going to risk this process? You have to remember, again, you hire talent. If you hire talent, let the talent be the talent. Let the talent figure it out what the problems you have and how to fix them, how to make the world better for everyone, for your clients, for your people, for the engineers in an organization. And the second thing is that the constant change. Everything in the company is constantly changing. As I said, a few months ago, we're still transitioning. We had a dedicated teams working on a dedicated services. Now we're changing the whole process of how the company will look at the products. That it's going to look at the products. It's going to be hiring for products instead of dedicated services. But the same thing is with the front end to back end. We do have to remember we majority at least of engineers is working on a constantly living and evolving systems. We constantly add features, we constantly remove some features which are not necessary anymore, or they are not, there is not too much interest about those features. And because of that, they're always gonna have to be like the communication between the front end and the backend. There are always gonna be changes which are gonna be affecting one or another. Because how our system works, we had a situations that the front end had to tell that, like, hey guys, you have to come up with something because we have a problem X which needs to be solved on your side. We can't do anything about it. It has to be centralized. And because of that, even more important is removing the boundaries and like dropping and unification of the processes, unification and getting people hand to hand working with each other is even more important, because again, it drives the client's value. Having clients, we had the situations, even with the current process, we had the situations, the clients were coming and they were telling like, hey guys, we're gonna go live with you, but we need a feature Y. And because of the well-defined processes and everything, we still were able to deliver them in a short period of time. With the new process, with the new design and new architecture, we're gonna be able even to do this probably twice as fast, because the testing will be easier, because the cooperation between the people will be better. And that's the main thing. By having a unified process, by having a single source of truth, it does allow us even to create a multi-person PRs if anyone will want to do something like that. But basically, we can create a PRs, we can include front-end, back-end changes, all of that protobufs. We can basically make this thing working from top to bottom right away, which is, again, like the adding new features, it's easier. Constant change, updating something in a system, removing things, refactorization. These are the things which are the most nerve-wracking. And even we had a situation, a backend team, they renamed the field on a feature which was not released yet. But again, because of the disconnect, because of the looking at two different sources of truth, front-end team didn't know what happened. They've seen a Swagger's updated, but they didn't understand they had a huge problem with understanding where this change is coming from, which PR created the change, because their Swagger looked like that. And at some point it changed. So they started to narrowing down, they started to looking for people which know something about it. They had to go through GitHub. Unification and getting back to a single source of truth, removing the boundaries, it just makes development cycle quicker, sooner, and more pleasurable for everyone in a company. So yeah, that's everything what I had. Does anyone has any question to me about the whole thing?
That was lovely. Thank you very much. I've had a look on the Discord site, and we don't have any questions at the moment, but feel free to chip in and we can answer them live. Okay, well, in that case, thank you very much, sir. Jolly good stuff. I like the bit about the empowerment. I think that's like a really important thing. I think if you don't do that, then people don't get to feel they're involved at all. But thank you, Alex. That was grand. Okay, I'll close the call down then. You're going to hang around on Discord for a while in case anybody else chips in, okay?
Sure, I will. Thank you so much.
Fantastic. Thank you. I'll end the call. Bye-bye.